Hey everyone, welcome back to Bon Science. Today we will be going over Unit 2, Topic 2 in AP Chemistry, which is called Intramolecular Force and Potential Energy. So let's get straight into it. So the first concept we're going to talk about is bond length, which is the length of a bond, obviously, but it's specifically only used when talking about covalent bonds. So it's not used for ionic or metallic bonds. And bond length is really dependent on two things. Bond length is dependent first and foremost on something we call bond order, and I'll discuss what that is in a moment. But the second thing it depends on is size. So let's discuss bond order for a moment because it can be a little tricky. So bond order describes the number of bonds between two atoms. And so you might be thinking, what do you mean the number of bonds, right? Like an atom's either bonded or not. It doesn't have multiple bonds. And to that I say, not really. So let's take a look at an example. So let's take a look at HF. So in HF, hydrogen shares one electron with fluorine and fluorine shares one electron with hydrogen, which forms one bond. But if we have carbon and nitrogen and carbon actually have three bonds, and these lines indicate bonds. We're going to learn how to draw these things later. They're called Lewis diagrams. This isn't even the full Lewis diagram, but we'll go over this later is my point. But essentially, what's happening between carbon and nitrogen is that they're sharing 6 electrons with each other. And so there's 3 different bonds. And so a bond is literally when two atoms share 2 electrons. So for every 2 electrons shared, you have a bond. So because hydrogen and fluorine share 1 electron, they have 1 bond, and they have a bond order of 1. But because carbon and nitrogen share 6 electrons, they have 3 bonds, which means they have a bond order of 3. So carbon and nitrogen have the higher bond order. And what you need to know for bond order and bond length is that a higher bond order means a shorter bond length. So a bond order of 3 is shorter. That means that the carbon-nitrogen bond was shorter than the hydrogen-fluorine bond, because a lower bond length means a lower bond order means a higher bond length. So that's bond order. Now size is really self-explanatory. I'm not even going to explain this one. A higher size of atoms means a longer bond length. A lower size means a lower bond length. That's really self-intuitive, right? If both of your atoms are smaller, your bond's going to be smaller. Simple stuff. Now, one thing you do need to know about bond length is that it ties into bond energy. Bond energy is the amount of energy required to break a bond. Shorter bond length means higher bond energy. And that's, I didn't mean to scroll down. That's just an application of Coulomb's law, right? Because less length, more energy. So what you need to know is the shorter bond length is, the higher bond energy gets. And on the AP exam, whenever they ask you about bond energy, you want to justify it in terms of bond length, at least for covalent bonds. If they ask you about bond energy on a covalent bond, think to bond length. And if you need to think about bond length, think about bond order and size. Okay, cool. The other thing in this unit, or this topic, is lattice energy. And lattice energy is bond energy for ionic bonds. So you have bond energy, which is covalent bonds, and then you have lattice energy, which is covalent bonds. Oh, and one thing I want to mention for what we just covered, bond order, so BO, is more important than size, which is to say, whenever you're trying to figure out bond length, bond order should be your first consideration. So if your bond order is higher, then you have a shorter bond. Don't even think about the sizes. But if they're the same, that's when you consider size. So just keep that in mind. Okay, so back to lattice energy. This is just bond energy for ionic compounds, and it depends on 2 things. It depends on charge of the atoms, and it depends on size again. And it's very similar to what we had going on with bond length. So a higher charge means a higher lattice energy. A lower charge means a lower lattice energy. And so essentially, if you had calcium oxide, CaO, as compared to lithium fluoride. Calcium has 2 plus, oxygen has 2 minus, right? So those charges are of a magnitude of 2. Lithium has 1 plus, fluorine has 1 minus, so these have a magnitude of 1. So calcium oxide has the higher lattice energy because its charges are greater magnitude. And so that's charge, real simple. And then size, it's probably what you're thinking. Well, size, this is energy, right? So it's actually inverse. So a lower size means a higher energy, and that's just Coulomb's law, right? Less radius means more force, more energy. So a lower size, higher energy, higher size, lower energy. So for example, if you had LiF and you had NaCl, sodium and chlorine are both bigger than lithium and fluorine, so lithium fluoride, or LiF, has the larger lattice energy because it's the smaller one. And then for lattice energy, charge is more important than size. So let's say you had, literally the last example is a really good example. So the CaO-LiF thing. So LiF is actually smaller, right? Lithium is smaller than calcium, fluorine is smaller than oxygen. So this is a much smaller bond. But because calcium and oxygen have the larger charge, they end up having the larger lattice energy, because charge is a more important consideration than size. So keep that in mind for lattice energy. But that's all you really need to know for this episode. So know that bond energy is the energy required to break a covalent bond. Lattice energy is the energy required to break an ionic bond. And then know the things that determine it. One last thing I do want to mention is lattice energy is directly proportional to melting point, which is to say, the higher the lattice energy of an ionic compound, the higher its melting point. That's just a little factoid you should know. But that's all you need to know for this video. So I hope you enjoyed it. I hope it was helpful, and I'll see you next time.